Okay, hello everybody. So today we're going to start into Chapter 6, Section 5. And what Chapter 6, Section 5 deals with is an application of what we learned in 6.3 and 6.4, which is using systems of linear equations to solve real life problems. And so we are going to use all of the different techniques. We could solve these by graphing. We could use these, solve these by substitution. We could solve these by elimination. There's not really one right way to do it. There's probably one most straightforward way, which I will discuss whenever we write the problems. So let's take a look at the first example. What you see here is a word problem. It says Courtney sold 40 tickets to a school play for a total of $245. If each ticket sold for $8, each adult ticket sold for $8, and each child's ticket sold for $3, how many of each kind did she sell? So there is enough information in here to write two equations. Now, if I had to pick the hardest thing about these problems, it is setting up the initial equations based on the information that you're getting in the problem. So I kind of go through this in kind of a methodical order, and I want to show you what we do. The first thing that we do is we are going to define our variables. We need to write what the variables are and what they represent within the problem. So we're going to start out by looking at what the question is, because the question can help you understand what the unknowns are so we can state what they are. So it says right here, how many of each kind did she sell? Now, when they say each kind, they're referring to the tickets, and we had two types of tickets. We had an adult ticket and we had a child ticket. Okay, so that is what X and Y are going to represent. How many adult tickets and how many children's tickets there are. So X is going to be the number of adult tickets. I ran out of room. Sorry about that. And Y is going to be the number of child tickets. All right. Now, in a problem like this, a scoring rubric, this would count for 2 points out of a 6-point problem. So 2 of your points can simply be gotten by just writing what the variables represent. Now, the next part is the trickier part. That's the part where we have to come up with information to be able to write two equations. So the first part is kind of, I think, a little more straightforward. It says Courtney sold 40 tickets. So that right there is what our first equation is going to be. We know X is the number of adult tickets, and we know Y is the number of child tickets. And we also know that the total number of tickets that was sold was 40. So if I take X and I add it to Y, that should equal 40. So there's our first equation. X plus Y equals 40. Now, the second equation is going to come from the rest of the information that's left. It said that the adult tickets were $8 each, and the children's tickets were $3 each, and she made a total of $245. And so in order to calculate how much money we made from each adult, from all of the adult tickets, you would take $8 and you would multiply that by the number of adult tickets, which in this case is X. So 8 times X would give us the total amount we earned from the adult tickets. Now, in addition to that, we also sold children's tickets. The children's tickets were $3 each, so 3 times Y. We don't know how many we sold, but we know there's Y amount. And what we know is the total sales altogether was $245. And so now we have our second equation. $8 times X, the number of adult tickets, plus $3 times Y, the number of children's tickets, will equal $245 total. So now that we have both of these equations, we can now proceed to solve them. So the question becomes, which technique do we use? Do we solve this by graphing? Do we solve this by substitution? Or do we solve this by elimination? And that really is up to you. I would probably tell you to shy away from graphing because graphing is not super accurate. It's kind of easy to make a mistake, and it's really hard to know exactly what the ordered pair is unless you're being super, super, super careful with how you're graphing. The better way is going to either be to use elimination or substitution. Um, I think for this particular problem, since both of the equations are in standard form, I am going to use elimination. And so what elimination requires you to do is to get two of the variables to be the same number. So that's what I'm going to do. I'm going to multiply this first equation. The easiest thing to do would be to multiply this thing by 3. And I'm going to multiply it by 3 here. I'm going to multiply it by 3 there. I'm going to multiply it by 3 there. Now I'm going to write a new equation. I'm going to write it below the second one because the second one's not going to change, and you'll see what happens. So I end up with 3x plus 3y equals 120. Okay, so there's my new equation. Now you can see that the 3's are now the same on the y values. So we can simply subtract these and it'll cancel one of the variables. So 8x minus 3x is 5x. 3x or 3y minus 3y is 0, goes away. And then we have 245 minus 120, and that becomes 125. The last step to this is to divide by 5 on both sides. And when I do that, I get x equals 2, 5. So what that means is x is 25. X is the number of adult tickets. So we know that she sold 25 adult tickets. Now we need to figure out how many children's tickets were sold. And to do that, we're going to use one of our two original equations. I'm going to use the x plus y equals 40 because it's the easiest one. And I'm going to plug 25 back in for x. So when I write x plus y equals 40, and I put the number 25 in for x, I'm going to subtract 25 from both sides to solve it, and I get y equals 15. So there you go. That means she sold 25 adult tickets and she sold 15 children's tickets. Now I'm going to skip to I'm going to do number 2. Then I'll do number 4. I'm going to skip number 3. So this is very similar to the last one. An adult ticket for a benefit breakfast costs $2.50. A children's ticket costs $1.50. It says if 56 tickets were sold for a total sales of $97, how many of each kind were sold? So once again, we're going to go through this step by step. The first thing we're going to do is define our variables. Okay, so we're going to have an x and a y, and it's the same as the last one. X is going to be the number of adult tickets. Y is going to be the number of child tickets. Okay, and then we need to come up, we have two variables, which means we have to have two equations. And the first one is going to involve a total number of tickets, just like the last one. It says a total of 56 tickets were sold. Total of 56. So that means X, which is the number of adults, plus the number of children equals 56. So there's our first equation. X plus Y equals 56. The second equation is going to involve the total amount of money that was made. Now, we know that the total amount of money made was $97. So we can set our equation equal to 97. But what we need to figure out is how much was each ticket. And it says an adult ticket was $2.50. So that's going to be 2.5 times X. plus a child ticket was 1.5 times y. And so we got our two equations. Now the last step is going to be to eliminate one of the variables so we can solve for the other one. And as you can see, once again, we have coefficients here and we have coefficients here, but none of them match. So to get them to match, we've got to multiply one or both of the equations by a number. In this case, I would say let's get the y's to match because that's a 1. We would like it to be a 1.5. So we're going to simply multiply that first equation by 1.5. So this whole thing is going to get multiplied by 1.5 here, here, and here. Okay, so when I multiply x times 1.5, I get 1.5x. When I multiply y by 1.5, I get 1.5y. When I multiply 56 by 1.5, it's going to be what, 28, so 70, it should be 84. It should be 84. I am going to double check very quickly that I did the multiplication right. 1.5 times 56. Yes, it is 84. Okay, so let's get rid of that. And so now you see I have this new equation that I can draw a line under. I am, again, going to subtract, so the y's go away. 2.5 minus 1.5 is 1. And then 1.5 minus 1.5 is 0, which is good. We need one of those variables to cancel, so we are able to solve for it. And then we have 97 minus 84, and that's 13. So there you go. X is 13. We know how much an adult ticket, how many adult tickets they sold. They sold 13. Once we know that number, we can figure out how many children's tickets they sold by plugging that number back in. So I am going to use the first equation, which is x plus y. X plus y equals 56. X was 13. When I subtract 13 from both sides, I get y equals 43. So that means they sold 13 adult tickets and 43 children's tickets. Now, I'm going to show you one more problem. Number 3 is very similar to the first two that we did. I'm going to show you this one, though. I want to show you how we deal with data in a table, because I think it actually makes the data easier to use. But it says, find the cost of 2 meals at a restaurant is shown. It says food, I'm sorry. The cost of 2 meals at a restaurant is shown in the table below. Find the cost of a taco and a burrito. And so what we don't know is the cost of tacos and the cost of burritos. So those are our variables. X is cost of taco. Y is cost of burrito. And we have 2 scenarios. We bought 3 tacos and 2 burritos, and it costs $7.40. So that's really that's our equation right there. 3x plus 2y equals 7.4. The second equation is going to be set up the same way. It's going to be 4x plus 1y equals $6.45. Okay, so now if you can see our variables, this is a 3 and a 4, so they won't cancel. This is a 1 and a 2, they won't cancel. So we need to do something to one of the variables or both to get them to be the same. It would be very convenient if this number right here, instead of being a 1, was a 2. You should always seek out the coefficient that's a 1, because you can multiply 1 by anything and turn it into any other number. So in this case, I'm going to make that 1 into a 2 by multiplying that entire second equation by 2. So this whole thing is going to get multiplied by 2. This, and this. So my first equation is just going to come over. 3x plus 2y equals 7.4. My second equation is going to become 8x plus 2y equals, and this is going to turn into 12.9. 9. Okay, now what you see is the two y variables, their coefficient is the same. So we can simply subtract them to get them to cancel. So I'm going to do 3x minus 8x, which is negative 5x. Then I have 2y minus 2y, which is 0. That goes away. And then I have 7.4 minus 12.9. And I'm going to do that on a calculator. 7.4 minus 12.9. And I get negative 5.5. Okay. Now, the last thing, let me move this out of the way so you can see what I'm doing. Okay. The last thing we need to do is divide this equation by negative 5. And when I do that, I get x equals 1.1. Now remember, x is the cost. So what this is $1.10 for a taco. Now, in order to get the cost of a burrito, we need to plug this x value back in. It doesn't matter which one we use. I'm going to use the second one because I think it will be the easiest. So I'm going to rewrite that equation. 4, then x, which I put 1.1 in for, plus 1y equals 6.45. Okay. Now 4 times 1.1 is 4.4. Now I'm going to subtract both sides by 4.4. And I get y equals 2.05. So that right there is going to be the cost of a burrito. So as you can see, that one was a little bit more tricky because of the numbers and the decimals, but the setup was the same. You defined your variables, then you wrote your equations, and then we solved them using, in this case, elimination. So I hope that made sense. As always, if you have any questions, feel free to email me. Have a great day.